Welcome back. Today we're going to be looking at Opencv in Python. So what is Opencv? Well, it's an open source library for computer vision, machine learning and image processing. It's free for academic and commercial use, so lots of companies use it. It supports many languages including C++, C, Python and Java. Of course, we're going to look at Python. And it works with many operating systems. And you can see Windows, macOS, iOS and Android. So the first thing we need to do is install it, and we can do this with pip install opencv python. And you can see that I've already got everything installed. So if we're going to import it, which we're going to do, we're going to call it cv2, which is the module name. We're also going to import time and OS, and we'll use those later. So the first thing we'll do is we'll just read this Python image that we used for the pillow lesson as well. So we'll just say that image is cv2.imread and then the file name. And we'll just print the image so you can see what it is. And you can see that this is a numpy array directly. So unlike pillow where we had a Python image object, here we've just got the array, and you'll notice that that means lots of the inbuilt functions take in that image rather than being methods themselves. And the other thing we should probably do is resize the image, because if you remember from last time it's very big. So we'll say image is cv2.resize image, and then the size will say 500 by 500. And you can see here that this function takes in this numpy array and resizes it. And then we'll want to display the image. So we can say cv2.imshow image. And we need a window name, so we'll call it image. And then mat is our matrix. And you can see it displayed very briefly, but that wasn't very good. And that's because what we need is to wait at the end. So say while true, time.sleep 1. So we'll just keep waiting. But again, you can see it's still not quite worked. And the reason for that is we actually need to wait. So we do cv2.wait key 1. And forgetting this line is very common, but it's very important. And this means that your image displays, as you can see. And if we close it, you can see that the window closes but the code keeps running, and that's because it's still in this while true loop. Moving on to videos, which I think Opencv is really good for compared to, for example, pillow. So the first thing is we need a cap, and that's a video capture, and the video we'll use is video.mp4, and it's just an example video, and you can see that if I do video.mp4, it's not a very exciting video. And then we'll here want to print cap, and for now we'll just comment this out and come back to it later. And you can see it's a video capture. So what can this provide us? Well, the first thing is we want the width, which is the cap.get cv2 dot, and then it's called the cap prop frame width. And we can do the same thing for the height, but this last bit is the height. And then we can print W and H. And you can see, however, that these are not integers, but because we're going to be using indexing, it's very important that we convert these back to integers. And that makes minimal change. We can also get the FPS, which is the cap prop FPS, and again we can display that here, and you can see that's a 30 FPS video. So what if we want to display the image? So the first thing we've got is result and an image, and that's cap.read, and result just says whether it's successful. So if it's unsuccessful, then result will be false and image will be none, and if it is successful, the result is true and image is a numpy array. And then we'll just display that. So we'll say image is result, and then copy this line and display our image. Except the image is not result, image is image. And you can see we've got this very large image, which was the first frame. So from now on, we're going to resize it to make it smaller. So I'm going to have scale is 0.5. And you can see here we resize the image. There's actually another way of resizing the image, and we can say image.resize. And again with the image. But this time we set the size to 0, 0, and we say fx is equal to our scale, and fy is equal to our scale. And so this is going to resize the image by the factor x and the factor y. And you can see that that's a lot more manageable and doesn't take up the whole of the screen. And if we want to keep looping through the video, we can say while result, we resize the image, and then we copy this line and we read again. And we do want to do these two things. So we'll take this, put it in here, and cv2.wait key 1. So this is going to get the image for the first time. It's then going to resize it, display it, wait, and then get the next image. And this should look a bit like an animated video. And it does. It's slightly quicker, I think, because of the way CV2 runs. And then at the end, we want to do a couple of things. We want to cap.release and cv2.destroy all windows. And then we won't need that bit at the end. And this means that it will close automatically for us at the end. So what we can then do is we could create a directory that contains all the frames from the video, so we can just extract the frames. So to do this, we'll use os. So we'll say if not os.path.exists, so we're checking if a path exists, and it's going to be called output, then we're just going to make that directory output. And this could be called something else, but this is quite a standard thing to do. We're going to have a counter, and I is 1, because it makes sense to start a counter at 1. We could start at 0, but I think it's nice to start at 1. And then after we've resized the image, we want to cv2.imWrite, and the format is going to be output / and then our value of I, and we can do it to 3 digits. So if it's 1, it'll be 001. If it's 10, it'll be 010. If it's 20, it'll be 020. And this means that they remain in alphabetical order, because otherwise it would go, 10, 11, and then eventually it would come to 2, and I find that very irritating. So I always make sure that they have a fixed number of digits. So we're going to write that, and then of course we need to increase I by 1. And we can loop through. And you'll see we've got this output directory with a lot of images. So you can see, for example, this is the 43rd frame of the image. And we can actually count the frames by saying ls output, and then we do wc minus l, and that tells us that there are 180 images. So the next thing that would be nice would be to display something in the images. So we might want to put some text that, for example, has the frame number. So what we'll do is we'll say that we're going to put text using the cv2 put text onto the image, and again we're going to display it as I03, and this is nice because it means it's a fixed length. And then we need to put the position, so it's called org here, and we're going to put it to the right, so that means that we take the width and we subtract 100, but we obviously need to multiply the width by the scale, and actually we'll subtract 80 instead. And obviously if this isn't an integer, then OpenCV runs into problems because it's expecting an integer. And we'll put it at 30, so it's slightly down. The font face, we're going to use Hershey Simplex. Unlike Pillow, there are a bunch of built-in fonts for OpenCV, which is nice. The font scale is going to be 1, so we're not going to resize it. The color is going to be white, and we'll make the thickness 2. And you can see now there's this counter in the top right hand corner. And if we click on a specific frame, we can see that that's been written as well, which is nice. Another thing that might make it nice is if we draw a rectangle in that top right hand corner as well, so that it's on a black background. So again, there's a method called rectangle, and we're going to draw it on the image, and again, and this time we want point 1, so the top left, or it doesn't really matter which one, but a point, another point, and then a color and a thickness. So the top point is going to be the top left, so we take the width times the scale, so it's smaller, and subtract 100, and the y is 0. And then again for the bottom right corner we multiply width by scale, and we make it 40. And the colour of this rectangle is going to be 0, 0, 0, which is black. Something interesting to note in OpenCV is that the colours aren't RGB, they're BGR, and that's really confusing. So 25500 you'd expect to be red, but it's actually blue. And that's something to watch out for, and if you ever wonder why your code is the wrong colour, that could be why. And then we put a -1, and this is saying that we want to fill in the rectangle. And we're actually going to put the rectangle before the text, so that the text is written on top of the rectangle. And that makes it a bit easier to read. And let's alter that output so that now they've got numbers on. However, I think creating this directory of files can be quite irritating. So instead what we're going to do is we're going to create a video as our output. And this is something that CV2 is really great for. Adding sound is a bit more complicated, so we're not going to do that. But we'll have a look at how we can just create a video. So the first thing we actually need is a writer. And this is a cv2.video writer. And the output is going to be output.mp4. Then we need to specify an encoding, so we use the video writer for CC, and you can see it's got C1, C2, C3, C4, and to do this we just take the phrase MP4V and spill it, which is easier. We then need to specify the frames per second and the dimensions, and that's W times scale and H star scale. So we did end up using the height in the end. And so we've got a video that will write to output.mp4 using this format at whatever frames per second the input was, with the width and height of the input. And the only difference here is where we're writing to an image file, instead we just say writer.write image. And so it continues to display, and we can then just say video.mp4, and then we can display the output, and you see we've got the counter in the top and it's written the video, so that's very nice. So you can see OpenCV is a very powerful tool for video editing and photo editing. It has some advantages over Pillow, like the fact that it's so easy to work with videos, for some disadvantages, like the fact that each image is just a numpy array. Hopefully you can see it's a powerful tool. You've enjoyed this video, learn how to use it, and I'll see you again, same time, next week. Till then.